Hello and welcome to Regrow Tech India. I'm your host, Duray Nayab, bringing to you yet another episode on the Java Beginners Interview Series. So, we have been discussing quite a lot of programs based on the while loops. And in the last few videos, we have looked at programs where we were finding out the various digits present in a number. And we said this concept is very, very important because we are going to use this particular concept, implement it in order to get some other logics done using while loops. So, this is one of those days where we are going to implement the logic of taking out a digit from a number and use it somewhere else. For instance, we are going to do a program where we have to check whether a number is a palindrome or not. So let's go on the screen and check out the question. So first of all, the question is quite simple. Write a program to check whether a number is a palindrome or not. Now, a palindromic number is simply a number that reads same when read forward or backwards. For example, 12. If I read it backwards, it will become 21. This is not a palindromic. But when I write 121, and if I read backwards, it will become 121, meaning this one is a palindromic number. Okay, it is a palindrome. There are several examples of palindromes. For instance, if I write 1, 2, 2, 1, if you write it in the opposite way, in the reverse manner, we will get 1, 2, 2, 1 only. Hence, this number is also a palindrome. Now, there are palindrome words as well. For example, madam. If you write it backwards or in the reverse manner, you will still get madam, making madam a palindrome. Okay, this is not something that we are going to learn today. What we are going to learn is to check whether a number is a palindrome or not. The logic is to take out one digit from the end and to join it like this. So basically, let us say we have 123. The logic is simple: to take out 23, sorry, to take out 3, and to 3 to add join 2 after that. So 2 here and then 1 goes here. This is the logic. But how we are doing it mathematically is something that we need to see. So what we are going to do is we'll start off by taking int, and I'm just writing the code for reverse of a number. Okay, so int n is equals to 123. Okay, I'll simply write while n is greater than 0. Then first of all take out the last digit. So ld is equals to what? 123. Oh, I'm so sorry. ld is equals to n mod n. What will this do? So if I do 123 divided by 10, 10 ones are 10, remainder 2, 3 comes down, 10 twos are 20, remainder 3. 3 is the remainder, so it will give me the last digit, which is 3. Okay. Then we want to actually do a reverse of that, right? So we said that there will be always two statements that will be there in this kind of code. One is to get the last digit. Second one is to move the loop. So here I want to update the n by saying n is equals to n divided by 10. So divided by 10, it should give me 12. So n will become 12 for the next time. But what we are doing in the middle is that in order to get a reverse number, we will write. So let's take int reverse is equals to 0. And here we will say reverse is equals to reverse times 10 plus the next LD. Meaning, so the next time the LD will be 2, right? So it will become, reverse will have 3, it will have 3 times 10, 30 plus 2, 32. Okay, so we will see, take a look at it when we are going to do a dry run. But the idea is to check if the reverse number is same as the original number. If that is the case, then the number is palindrome. Okay, so I know I have not explained the dry run so well here because I want to write the entire code first and then explain to you the dry run again. Okay, so first let us move to Eclipse and write a quick code here. Here we go. So I've already written the main function and everything. Let us go ahead and first let's say int n is equals to 123. Then we will say while n is greater than 0, we want to take out the last digit. So int ld is equals to n mod 10. Then we will have n equals n divided by 10. And after that, we will want to take out reverse. So reverse is equals to reverse times 10 plus LD. Okay. And since reverse is not defined here, we will quickly go on the top and we'll say int reverse is equals to 0. Okay. Now, what I need to simply check here is that if reverse equals to n. But the problem here is that by the end of the loop, n will become 0. So what I'll do is I'll take yet another integer variable, let's say int n1, and I will store the value of n here. So that when I'm comparing, instead of comparing with n, I will compare it with n1, which also, by the way, has 123. Okay. And as to why the n is not going to be 123 after the end, at the end of while loop, we will discuss it in the dry run itself. Okay. So if reverse is equals to n1, we will say the number is palindrome. Else not a palindrome number. There we go. Yeah. So let's go ahead and run this. So this one says it's not a palindromic number. Also, I just want to show you a quick statement as to what is the reverse number as well. So reverse colon plus REV. Okay. And the reverse number was 321, which is not same as 123. That is why it is not a palindrome. If I change this to 121, and you will see the reverse is also 121. Hence, the number is a palindromic number. Okay, that is one. The next thing, I also said that the n is not going to be same in the end. It will not be 123. So let me also print here the value of n and show you. So as you can see, the value of n in the end is 0. Okay. Earlier, we did store it at 121, but it turned out to be 0. Why that happened, we will discuss that in the dry run. So let's quickly go ahead and take this code on the Miro board where we are going to check out the dry run of the code. So here we are. Okay, so the code I've put here, let us go ahead and start doing the dry run for this. So first of all, it will read int n is equals to 121. So n will be equals to 121. That is the first thing. I'm also saying int n1 is equals to n. So n1 is equals to n. What is there in n? N has 121. Therefore, n1 also will have 121. Next, the reverse is equals to 0. So reverse is supposed to have 0. Next thing is, while n is greater than 0, right now n is 121, it is most certainly greater than 0, meaning it will go inside the loop. Okay, it will go inside the loop, and what will it do? It will first take out int ld is equals to n mod 10. So we will have ld n mod 10, it will take out 1. That is the last digit. We have already discussed as to how the division will happen, and we'll get the last digit. So we got the last digit as 1. Then we are doing n is equals to n divided by 10. So n divided by 10, we will get 112. Okay, and I hope you remember we did this 123 when we were dividing. 3 was the remainder and 1, 2, the rest of the digits was in the quotient. So you basically want the rest of the digits. Next, it says reverse is equals to reverse times 10. So first of all, whatever is there in reverse, right now reverse has 0. So 0 multiplied by 10 is 0 plus LD. So it says here reverse into 10 plus LD. So reverse is 0, 0 times 10 is 0 only plus LD, LD is 1. So therefore reverse will now become 1. Okay, once that is sorted, again it comes to the end of the while loop, and since it is here at the end curly bracket, it will go back again to check the condition of the while loop, whether it is meeting the condition or the condition is false now. So it will check while n is greater than 0. So right now n is 12. It is most certainly greater than 0. So it will go inside the loop again. Okay, and it will get LD is equals to n divided by 10. So right now n is 12 and n mod 10 would be, so 12 divided by 10. 10 ones are 10, remainder is 2. So remainder 2 will be here. Okay, 2. Yeah. Next, n is equals to n divided by 10. So whatever is the quotient will come here. This will become 1. Next, reverse is equals to reverse times 10 plus LD. So whatever was reverse earlier reverse was 1. It says 1 times 10. 1 times 10 is 10. 10 plus LD. So right now LD is 2. 10 plus 2 is 12. So reverse now will become 12. Okay. Again, it has reached the end of the while loop. So it will go back again to check whether the condition is still true or has become false. So the condition is while n is greater than 0. So right now n is 1, which is greater than 0. So it will go inside the loop. It will again take out the last digit. Now 1 divided by 10. 10 zeros are 0 and we will have the remainder as 1. So LD will be 1 again. Okay. Now n is equals to n divided by 10, which was 0, the quotient was 0, so 1 will become 0. N value is now 0, and that is the reason why when we were printing n here, we were getting 0. Okay? Next, coming back here, we want reverse is equals to reverse times 10 plus LD. So right now, reverse has 12. 12 multiplied by 10 is 120, right? 120 plus LD is 1, right? So 120 plus 1 is 121. Now as you can see, we wanted the reverse. We have already gotten the reverse, right? Now again it has come to the end. It will go back here and it will check while n is greater than 0. Right now n is equals to 0, meaning the condition has become false. It will stop going inside the while loop and it will print the next statement. It will execute the next statement, which is here in this case system.out.println n. So n is 0, that got printed. Reverse, again we are printing, so reverse is 121, that will be printed. Next, if rev is equals to n1. Now, again, I want to circle back to a previous question that we asked, that why did we take a variable n1 when we already had n? And we said because the n value will change when it goes inside the while loop. And I think it is already proved that the n value has changed. It has become 0 at the end of the while loop. Therefore, if I check whether rev is equals to n, now n is 0, reverse is 121. Of course, they are not going to be equal. We want them to be equal so as to say that, okay, the numbers are palindrome. That is the reason why we stored the value of n in some other variable n1. Clear? And then we said rev is equals to n1 system.out.println palindrome number. So if n1, which is 121, is equals to the reverse value, which in our case is 121. So n1 is 121, reverse is 121, they are equal. So our output is going to be palindrome. Okay. This is the dry run as to how the program is going to run. Okay, I hope palindrome program is understood. It is a very easy topic. If you understand how to take out the last digit, all you need to do is learn how to get the reverse value. So reverse value is nothing but whatever is the last digit times 10 plus the next last digit. That is why we are doing reverse is equals to reverse times 10 plus the last digit. Okay, that is a simple logic there. And after that, we are checking if the number is same as reverse, then palindrome, otherwise no palindrome, right? That's literally the program. I hope it is understood. If you want us to take up any more programs regarding while loops, you can always put them on the comments. Other than that, if you like this video, please hit that like button and subscribe. Have a great day ahead.